Hi everybody, this week we are focusing on adding and subtracting numbers, including rational numbers. That means including fractions and decimals. So last week we were introduced to this idea and we've used different strategies to add and subtract using a number line and various other visual ways. So one of the things I want to recap before we get started is this idea of absolute value. And this is something that we looked at last year. Absolute value, I don't think it's come up this year so far, but absolute value of a number is its distance from zero. So for example, we have these signs to represent absolute value. This says absolute value of -2. So what we're really asking for this is what is the distance that -2 is from zero? Well, -2 is 2 away from zero. So the absolute value of -2 is 2. The absolute value of 5 is the distance 5 is from zero. That's just 5. So basically, absolute value, if you're just talking about the absolute value of a number, it's a positive number. It's looking at the distance away from zero without taking into consideration its sign. We're going to use this when we add and subtract with numbers. So we'll just do some examples here. And basically, when adding integers, and positive and negative numbers in general, actually, I should not have put just that word there. The sign of your answer is the sign of the number with the greatest absolute value. So this is what I mean by that. We take a look at the numbers involved. For example, I have 6 plus -4. What we've really got there are the number 6 and the number -4. It's +6, -4. Which one of these numbers has the greatest absolute value, 6 or -4? Hopefully, you think it's 6, and that means that your answer is positive. So that's all that it tells you so far. It tells me that the answer to this, because it's an addition problem, the number in the addition problem with the greatest absolute value is 6. So my answer is the sign of this, and this is a +6. There's no sign there, but so that means it's positive. So I know my answer is positive. And then I take a look at these, and I know the different signs. That's positive and negative. And if the signs are different, we're going to subtract them. And we're subtracting at this point the absolute value. We've already determined it's positive. So I'm finding the difference between 6 and 4. And that's 2. Let's do this a few times because I know it's confusing. So again, this is an addition problem. I have the numbers -10 and -9. Well, they're both negative, which makes it a bit easier. But I can also ask the same question. Which one of these has the greatest absolute value? -10 does. So the answer to my problem is negative. I know it's negative. And now that I've already determined that it's negative, I can ignore the signs in my addition problem. And because they're the same, I'll add them. In other words, 10 and 9, 19. So it's -19. Let's take a look at this next one. I've got the numbers -3 adding to 7. Which one of these numbers has the greatest absolute value? -3 or +7? Hopefully, you also agree that it's +7 has the greatest absolute value. That means my answer is going to be a positive number. The signs are different. This is negative and this is positive. And if the signs are different, we subtract the absolute values. We've already established it's positive, so I don't care about the signs at this point. The difference between 7 and 3 is 4. So the answer to my problem is 4. So this is a slightly different way that the book approaches this problem, but I do think that this is a reliable way to add different numbers. And the same rule applies. You would do the same thing even if they were decimals or fractions. So that's addition. Okay, well, when we subtract, we can always think of a subtraction problem as an addition problem instead. You don't have to do this, but I do think it's easier. So for example, 8 take away 12 is the same thing as 8 plus -12. We do want to be comfortable changing this to become an addition problem instead. So I can do this in exactly the same way. Which one has the greatest absolute value? +8 or -12? -12. So I'd write negative sign there. Are the signs the same or are they different? Well, they're different. That's positive, that's negative. So I'll find the difference. In other words, I'll subtract. 12 take away 8 is 4. So I always recommend determining the sign first. Okay, this is an interesting one. We've got 5 take away -8. This is the same thing as 5 plus 8. Think about when you have a double negative in words. If you say, I didn't do nothing. I didn't do nothing, that actually meant you did something. It negates the negative sign. So this can be rewritten as 5 plus 8, which, okay, we can just work this out, but we could also ask ourselves the same question. Which one of these has the greatest absolute value? It would be the 8, so that means your answer is positive. Signs the same, are they different? They're the same, they're both positive, fine, so you just add them together. Of course, I didn't need to do that for this particular question, but it still works, right? Okay, so this one here involves decimals. Same thing, I'm going to rewrite it as an addition. So 0.2 take away 1.1 is equivalent to 0.2 plus negative 1.1. And again, I'm going to ask that question, which one of these numbers has the greatest absolute value? Well, that means the furthest from 0, which would be negative 1.1. That means our answer is going to be negative. And I've got a positive number and a negative number. The signs are different in my original addition problem, so I'm going to find the difference between 1.1 and 0.2. And that will give me 0.9. So it's negative 0.9. So this is just one way of adding and subtracting numbers. I always recommend turning your subtract problem into an addition problem. I do it myself. You know, there are exceptions. There's times you don't need to do it. But a lot of times doing it this way does make it less confusing. So this is what we'll be practicing this week.